Okay, hello. Whoops, let me move that up. Alright, so today we will be talking about a spin-off of the question that I did yesterday. Not sure if this is on Leetcode, because I'm yoinking my friend's interview prep stuff. So, we're gonna be doing this on VS Code. Still on with Python though. There won't be that many test cases because, well, I'm not like Leetcode having like 100 test cases. We'll just be using the 3 sample ones. So basically, it's the same thing as what we did yesterday. There's just a slight tweak in what we need to do in order to keep track of the numbers that we want to return here. And so yeah, it's the simple start. We're doing a while loop, so while I is less than length of nums. And from here, same thing, j is equal to nums I, right? And so if j, we want to sort these things. I guess I shouldn't say the one that I did yesterday, but basically it would be similar to find the first missing positive number, which is another video that I did. Yeah, I've realized that this is probably like individual videos. Well, these are individual videos, so I should still explain each problem like correspondingly, right? So basically what we want to do is do a while loop. So this is our basic while loop setup. This is basically finding out where the number belongs, or like what number we're looking at, and then we're going to determine here in this if statement whether or not we need to do some cyclic sorts in order to put the number where it belongs. And since we want the first missing positive number, we want to sort from 1 to n. So for example, we want to start from 1, 2, 3, 4, 5, etc. all the way to n. Right. We want this because we don't care about 0. 0 is not considered a positive integer. So we'll start like this. And in order to determine, where the number belongs, we just have j, which is just whatever number we're looking at. So if we're looking at example 7, we're looking at the numbers. Example 1, sorry, we have the number 7 in the first index, right? So we want to do 2 things. We want to make sure it's greater than 0, because that's when we know we want to sort it. If not, we don't care. And we also want it to be less than the length of nums. Actually, no, less than or equal to. Because since we're one number over, like we care about, for this array, we would care about 1 through 5, right? And so we would include the length of the array, that number, as part of the numbers that we want to sort. So it'd actually be less than or equal to here. And the final condition, whether or not we need to sort, is if it's in the wrong position. So if the number that we're currently looking at, actually, we could actually just use j here, right? But I guess it's kind of confusing, so we'll just use this. If this number that we're looking at doesn't sit at whatever number we're looking at minus 1, that index, we want to hit the swap. So basically, like 7, we'll look at a number that actually exists. So here, with this example right here, with this example here, when I is equal to 3, because 0, 1, 2, 3, right? When I is equal to 3, nums I would equal to j, which is also equal to 2, right? And so our nums, and we want 2 to reside at index 1, right? So basically we want 2 minus 1. And since j is 2, then we can just substitute j here, right? And so that's where we want this to exist. So that's how that works, right? So we want index for it to exist at would be j minus 1, right? So that's the logic behind this. And from here, whoops, pressed enter one too many times. And from here, we will just hit a simple swap minus 1, nums j minus 1, nums I. And else, so if, you know, if we do, if we don't do it, like if we needed to swap, then we'll swap. If not, then we're going to do I plus equals 1, right? So that's pretty simple up to now. And so now we're going to have our result array, and we're going to have a scene. So whoops, I meant to put an equal sign, not comma. So we want to initialize a set, because for the numbers that we've seen, we only want to care about the numbers. Like for example, this one, right? We don't need to have both 3's in the array. Like we could have this be a set, right? A list, and we can just append everything that we see. But honestly, we only care about the unique numbers that we see. So we'll just use a set. And so for index in the range of length of nums. So now in this for loop, we want to check to see what numbers we're missing within the array, and then append those as part of the list, right? So if nums I, nums I doesn't equal to I plus 1, oh no, not I. Made this in the mistake in the find the first missing positive, but I won't make it again. So basically, for every index, if the number's index does not equal to index plus 1, because like we said here, we only care about 1 through n. So theoretically for this, if we had all the numbers, it would be 1, 2, 3, 4, 5, right? But then the index is always 1 behind because it's 0-based indexing. So 0, 1, 2, 3, 4. So if we just do index plus 1 and we index into it, they should be the same if we have the number, right? If not, actually, there's another condition that we need to add. If the length of results is less than k, then we want to look for more numbers, right? Because if the length of results is already equal to k, like since we won't go higher anyways, if the length of results is less than k, then we need to look for more numbers to add in order to satisfy the result, right? To satisfy the requirements of the result to have k amount of numbers. And so if it's less than k, then we keep going. Otherwise, you know, we might have to, you know, abandon early, in a sense. Like for here, right? If we look at this index, we see because this is already sorted. Okay, we wouldn't do anything to sort this because they're all less than 0. So we wouldn't do anything to sort it anyways. So we look here, it's not 1, so we append it here. And we look here, it's not 2, so we append it here. So we already have our result, right? And so we can just go through the rest of this array not doing anything, because we don't want to append 3, 4, 5, because we only want the first 2 numbers, right? So we could just stop it using that if statement. And so basically if it's less than k, then whoops, we're going to check if it's not equal to it. If it's not equal to it, then we want result dot append nums. We'll just do index plus 1, right? And then we're in our scene, we're going to dot add nums index, because what case would this be? This would be for this case, right? So if we were to sort this, sorted input would equal to would be 7 to, would swap those, and it would be swap -1, 4, 9. So it would probably end up being swapped like this, because the 2 and -1 get swapped, and then the 4 and the -1 will get swapped, and 9 doesn't get touched. So sorted input would look like this, right? And so if we look at this, we see like, hey, we actually, wait, wouldn't you want to move this outside? Because regardless of the thing, we've seen it, right? Yeah, so regardless of whether or not we see the thing, regardless or not we need to add the number, we've seen the number. I guess, would it even matter? I don't think it would matter, because I don't think there's a case where it's equal. If it's equal, then it's not even a missing number. Right? Yeah, if it's equal, then it's not even a missing number. So actually, yeah, we can just keep this in here. And so this will build out our result for for at least all the numbers in our array, if there's anything that needs to be changed. And so we have the we'll call it just like, okay, we'll call it just temp. We'll just call it temp. So basically, this number is only used if we need to, if this array doesn't give us enough numbers. So for example, none of these examples do it actually. So if I were to come up with an example, at least example 4, input would be 1 2 3, whatever, we'll just do 1 2 3, right? And yeah, so the output, oh actually no, I need to give it a k. K is equal to, let's just say 3, right? So our answer would be 4 5 6, and explanation would be the smallest missing positive numbers are 4 5 and 6, and 6, because 1 2 3, 1 2 and 3 all exist within the array, and we don't, yeah, that's good enough. They all exist within the array. So for this, we wouldn't see anything, right? So we wouldn't, we'll check this and it is equal. And like, so basically there's a hidden case, right? So if nums index plus 1, don't, just do nothing. Just do nothing. Right? Yeah. So basically in that case, we would need to go above the whatever the contents of the array. So if the length of result is less than k, because we need at least k numbers in result, right? If temp not in scene, then we will do result.append temp, and then we do temp plus equals 1 and return result. Let me move that up a little bit. Yeah, so basically here we iterate through, we have the number, we determine whether or not we want to do perform a cyclic sort based on our condition of wanting to be between 1 through n, and then we want to see if the number exists in the array, like if the number should exist within the array, and then we'll perform a swap. If not, we just increment I. We set these variables just so we can see this is our result, and this is just say what we've seen so far with for loop to go through everything in the array. If the length of result is less than k, then we want to find answers within our array. If nums index does not equal to index plus 1, so basically if index 0 does not equal to 1, then we want to append whatever index plus 1 is, because that's the number we're looking for. And then the scene, we'll do dot add the nums sub index, because in something like, let's just say for example 1, if we add the numbers 1, 3, and 5, right? I guess 7 will end up being here, but like 9 wouldn't, right? I guess if I just put another 1, I guess, right? Then we will get 1, 2, 3, 4, 5. So the first numbers are 6, 7, 8, and then 9, right? 9 would exist right outside of the array because this is 8 indices long. And so, actually no, that's what I was trying to do. So basically, if I do have the 9, right? So 9 does exist, so basically 1, 2, 3, 4, 5. So the answer here would become 6, 8, 6, 8, 10. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, yeah. And so we would have to keep track of the 9 because it's not a missing positive number because we've seen it. And so we'd have to skip over that at the very end, right? So that's why we have the scene. And if it does belong in the index, we don't need to add it because we won't run into the case where we have to try to calculate it at the end of the array, right? And then so we'll have a temporary number. You can call this whatever, really probably a better name, but I can't think of one right now, so I'm just going to call it temp. It's equal to length of nums plus 1 because we'll go with the short example. This is length of 3. The first number we will run to out here would be 4, right? So that's why it's just length of nums plus 1. You can fact check it with this. This length is 4. The first number we'll run into is 5. This length is 8. First number we'll run to on the outside is 9. So and so. This first number will be 6. If everything was in here, of course. So yeah. And so while the length of our result is still less than k, we need to keep going until, we find our number. If temp not in scene, if this temp number is not, if we haven't seen it going through the array, then we will append it and then we increment it. Even if it is in scene, we still need to increment it because otherwise we'll be stuck there forever. And then we want to return result. And so if I run the Python file, hello? Is it going? Why is it not going? I is equal to 0. While it's less than the length of nums. This is this. Increment here. Result is equal to array. Scene is a set. Index, 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 index. So we'll go through this regardless. Temp, while length of result is less than k. It's not in scene. Then res.append temp, temp plus equals 1. Huh. Well, let's see. We do some simple debugging. Hello. And then I shouldn't see this. Oh, whoops, I should probably not do that. Probably just do this and then this and then, whoops. And then we will run Python file. We go hello and it probably gets stuck, right? Which makes sense. So now we will check. Do we get here? We don't get here. So it must be breaking in. Okay. Do we get here? Wait a second. Probably trash that one. Run Python. So we don't get there. If j is greater than 0 and j is less than or equal to the length of nums, and num sub I does not equal to nums j minus 1, nums I, nums j minus 1. Aha, I didn't do an equal sign. So now we will run Python file. So 135. Okay, I should probably change that back, huh? So if we get this array, our numbers will be 1, because 1 is not found in there, 3, and 5. And then 156, because 1's not here. 1, 2, 3, 4, 5, 6. 3 numbers, right? 156. Here we're looking for numbers 1 and 2. I guess I'll add this one too. So 1, 2, 3, and k3. We'll do print find first k missing positive. 1, 2, 3. Comma. We want 3 numbers, is that right? 3 numbers here. So if we run it again, we get 4, 5, and 6. And that is right. All right. Little slight hiccup, but yeah, that is it. Thank you.